All right, we've got activity 33, and this one is mostly about the quadratic formula. Now, the quadratic formula I have written on the board on the right-hand side of my room, but I'll write it right here. Let's see, let's get the pen. Okay, so it's x equals, let me get this out of the way. So it's opposite b, so you take whatever's b, add and subtract, so it's two problems. And you got b squared minus 4 times a times c. Redo this so it's not so big. And then on the bottom, you got 2a. Now, start this one off, it's asking for the discriminant. And what the discriminant is, it's a big word. All it means is we're looking for this information that's underneath the radical. So this b squared minus 4ac. And when we solve this, it's going to tell us a couple things. And I already have the answer filled out in this one. But what happens is when we solve underneath the radical, if we have a perfect square, except for 0, so like 1, 4, 9, 16, 25, 36, 49, 64. If anything underneath, whenever I solve this discriminant, if it's a perfect square, if I can take the square root of it and I get a whole number, I'm going to have two answers because I have to add and subtract that number. That's what that plus minus means. This thing I in here in red. So I'll have two distinct rational numbers. Now, a rational number is whole numbers, no decimals. Oh, well, they can be decimals, but like no, like pi, where I don't, when I have a decimal, it goes on forever. It never repeats. I can't write it as a fraction. So I would say, really, we're just looking for a whole number. Whole number. Let's just write that. Okay. Well, not even that. It's just a perfect square. And you can check. If you get something you don't know if it's a perfect square or not, just take your calculator, do the square root of whatever number you get. If it's a perfect square, no decimals, you're good to go. If you get a number that's not a perfect square, you still have two answer choices, but they're irrational solutions. And I'll show you what that looks like. Okay. And these are both positive, so I should probably write that on there too. Positive. If you get a negative number, you're going to have solutions that include an I. And then if you get 0, you'll have just one rational solution. So what we're going to do is, in this original problem, we're just going to take the information that we have, and we're going to plug in the discriminant. And I'll kind of show you what I mean here. Okay, so we got whatever b is squared minus 4ac. So here I got 5 squared, and then we got a negative 4, and then I've got 3. Well, that's 25. And then 16 times 3, well, negative 4 times negative 4 is 16. Times by 3, I think is 48. And then, yep, plus 48. So if I add those two together, I get 73. And I get 121. Now, if I take the square root of 121, that's going to give me 11. So this is a perfect square. So therefore, I have two rational numbers, because if I were to do the quadratic formula, it would give me two nice even numbers. Well, fractions, at least fractions. It wouldn't be an irrational number. It might not be a whole number, but okay. So let's try this again. So all we're doing is we're doing b squared minus 4 times a times c. We've got some pretty big numbers here, so calculator is obviously going to be useful. So we got opposite b, and then minus 4a is 49, and then c is 36. And all I'm going to do is I'm going to plug this in my calculator as exactly as I see it. I don't really have to do anything else with it. So I'm going to do, and you can't see what I'm doing, but that's what I'm doing right now. I'm just plugging this whole thing right in my calculator. So I got negative 4 squared. Negative 84 is inside parentheses. So negative 84 squared minus 4, and then a would be that 49, and then the c would be 36. And I already know my answer because, well, where I'm pulling these problems from already tells me. So it should be 0. I click enter. This whole thing does equal 0. And so what that would look like is on my quadratic formula, I'd have that opposite b plus minus square root of 0 over to whatever a is. And all I'm doing is, well, this simplifies. So if I do negative b plus minus 0, well, that's just one answer. It's the same. So that's why it is a single rational solution. Okay, go on to this next one. You got opposite, so b squared minus 4 ac. And let's see, 21 minus 4a is 30, then 3. And so I'm going to go plug this right into my calculator. Got 0 minus 4a 3 0 0. Oops. So this gives me 81. And right here, I guess this one I included the work part of this. Okay, so I got two distinct rational numbers. Then lastly, let's do this one. So I've got 2 squared minus 4a is negative 1. C would be negative 3. Plug that in my calculator. I get 2 squared minus 4, negative 1, negative 3. Give me negative 8. Now, if I take the square root of a negative number, I got to get into some complex or non-real zeros. It's different verbiage, same thing. Square root of 8. So you still have a plus minus when you plug this into the quadratic formula. Whoa. And 2, whatever a is, I think it's the negative 1. But you're going to have two complex or non-real zeros. So anytime you get a negative, you can still do it, but you're going to have some not so fun answers. All right, so let's move on to the quadratic formula. First things first, we need to get this into standard form. And so what I'm going to do is I'm going to distribute this 4n. Zoom in a little bit here. So I get 4n squared minus 20n plus 25. And that equals 0. So it's going to use that opposite b. I got opposite b plus minus square root b. I always make this so small. B squared minus 4 ac. All that is going to be over 2 times a. So I got negative 20, then negative 20, then 4, 25, and then a 4 down here. Now, use your calculator on these. So I know that a negative 20, so that's going to give me a positive 20 plus minus. And then in my parentheses, I got negative 20 squared minus 4 times 25. Look at that, gives me 0. So I know from before, because my discriminant, that thing underneath the radical is 0, I'm only going to have one solution. Let me simplify. I got 8. Well, 20 plus or minus the square root of 0 is just 20 plus or minus 0, which is equal to 20. Got to divide that by 8. And both those are divisible by 4, so that should be 5 halves. I only have one answer, which is awesome. And I guess it wouldn't even be x, it'd be n. Okay, let's try that again. I'm going to distribute here, so it gives me 5d, and I already have the answer, but 5d squared minus 20d plus 20 equals 0. So opposite b plus minus square root of negative 20. Well, I'm plugging it in already. A is 5. And then I got 20 divided by 2 times 5. And I got a negative 20 right here. Simplify the negative 20. That is a positive 20 plus minus 5. I get 0 again. Plus or minus 0. Square root of 0, which is 0. So 20 over 10. That's why I get 2 as my answer, which I had right here. Okay, I have my answers written down here. It doesn't change what I do. This one, as you can see, it's a bit messy. And I wanted to bring in one where we got a negative, so we had to use an imaginary number. And then also one that didn't have a perfect square, so we can kind of see how those answers are written. I'm going to solve this the same way. I'm going to go about it. And I'm going to distribute. So I got 2y squared plus y plus 10 equals 0. Okay, so I'm just going to fill out my formula. Opposite b plus minus square root b squared minus 4 ac all over 2a. And I've got 1 is my b value, so that goes right here. I got a 2 as my a value, and then I got a 10. So let's simplify. So I got negative 1 plus minus square root. 1 squared is 1. And then I got 4 times 2 is, so under here, my discriminant, I got 1. 4 times 2 is 8 times 10 is 80 minus 80. So that's going to give me square root of negative 79. And all of that is divided by 4. Now, the way that it wants this answer is I need to pull out the imaginary numbers. So I got negative 1 plus I root 79. The negative 1 is, the square root of negative 1 is I over 4. And then I got a second answer where it's negative 1 and then minus I root 79 over 4. It writes it a little bit differently. It writes it as 2 fractions. I think either one of these will work. I like to keep it as just one denominator, but since we have a common denominator right here, they essentially mean the same thing. Okay, that's it for today. There is a 33 part 2, but I didn't want to do that when I wasn't here. So we're just going to kind of shift everything a little bit. We're still ending with 40 on December 5th, but I will see you guys on Friday and talk to you later.